Okay, so I'm going to begin with some mental arithmetic. 38 times 42, 1,596. 93 times 107, 9,951. 316 times 284, 89,744. 4,996 times 5,004, 24,999,984. 48 times 53, 2,544. 55 squared take 45 squared. 1,000. Isn't it 1,000? I think so, yes. 68 squared take 32 squared. 3,600. 137 squared take 63 squared. 12,800. 1,250 squared take 750 squared. 1,000,000. 73 squared. 73 squared plus 27 squared. 6,058. Okay. Set number 2. 94 squared. 8,836. 1,008 squared. 1,016,064. 989 squared. 989 squared. All right, let's think. How do you do this? Okay, so I need to establish what the actual pattern is, because otherwise this is going to cause repeats. Okay, so yeah, 9 squared is 81, of course. 99 squared is 9,801. All right, so it should look like that. 978,121. 10,003 squared. 100,060,009. 10,040 squared. 100,081,600. 47 squared. 2,209. 54 squared. 2,916. 203 squared. 41,209. 496 squared. 246,016. Yeah, okay. 2,504 squared. 627,016. All right, just one more set here. Okay. 75 squared. 5,625. 125 squared. 15,625. 205 squared. 42,025. 995 squared. 990,025. 84 squared. 7,056. 43 times 47. 2,021. 71 times 79. 5,609. 26 times 86. 2,236. 118 times 112. 13,216. 63 times 68. 4,284. Okay, now we can get started on chapter 13. Okay. Okay, so we begin with indefinite integrals. Indefinite integrals. Integrate 3x squared, take 8x at 5 dx. X cubed, take 4x, add 5, plus c. No. X cubed. X cubed, take 4x squared, plus 5x plus c. So x cubed, take 4x squared plus 5x plus c is the integral of 3x squared is the integral of 3x squared, take 8x, add 5 dx. Integrate 2x, add 1 times x take 3 dx. Okay, so we expand the integrand. To get 2x squared, take 5x, take 3. And then we integrate. To get 2/3 of x cubed, take 5 over 2 x squared, take 3x plus c. So 2/3 of x cubed, take 5 over 2 x squared, take 3x plus c is the integral of 2x head 1 times x take 3 dx. Integrate x cubed add 2 all over x squared dx. Break it apart. So that's the same as asking, what's the integral of x plus 2x to the minus 2 dx? Which is a half x squared, take 1 over x plus c. So half x squared, take 1 over x plus c is the integral of x cubed plus 2 all over x squared dx. Integrate 6 over x squared plus 4x dx. Minus 6 over x plus 2x squared plus c. So minus 6 over x plus 2x squared plus c is the integral of 6 over x squared plus 4x dx. Is that right? Yes. All right. Integrate 1 add x all squared dx. Okay, that's the same as asking what's the integral of x squared add 2x add 1 dx. Which is a third of x cubed plus x. Which is a third of x cubed plus x squared plus 2x plus c. So a third of x cubed plus x squared plus 2x plus c is the integral of 1 plus x all to the power of 2 dx. Right? Okay. Finding functions. A curve has dy by dx equals 4x and passes through 1, 5. Find y in terms of x. Okay, so integrate 4x dx. And you get 2x squared plus c. So y equals 2x squared plus c. Set x to 1 and y to 5. So c is 3. So y equals 2x squared plus 3. So y equals 2x squared plus 3 when dy by dx equals 4x and it passes through the point 1, 5. Come on. Given f prime of x equals 3x squared, take 2, and f of 1 equals 4, find f of x. Integrate f prime of x dx. The answer is x cubed, take 2x, plus c. X cubed, take 2x plus y. F of x equals x cubed, take 2x plus c. Four equals 1 cubed plus 2 times 1. plus c. So c is 1. So f of x equals x cubed plus 2x plus 1. So f of x equals x cubed plus 2. No, that should be a minus. Alright, fine. I have to do it again. Given f prime of x equals 3x squared, take 2 and f of 1 equals 4, find f of x. Alright, so f prime of x equals 3x squared, take 2. So f of x equals x cubed, take 2x plus c. So 4 equals 1 cubed, take 2 times 1 plus c. So c is 5. So f of x equals x cubed, take 2x plus 5. So f of x equals x cubed, take 2x plus 5, when f prime of x equals 3x squared, take 2, and f of 1 equals 4. Okay. A curve has dy by dx equals 6x, take 4, and passes through the origin. Find y in terms of x. If dy by dx equals 6x, take 4, then y equals 3x squared, take 4x plus c. But it passes through the origin, and so we get 0 on both sides. So y is indeed equal to 3x squared, take 4x. So y equals 3x squared, take 4x, when y is equal to 6x, take 4, and the curve passes through the origin. No, wrong. Y is equal to 3x squared, take 4x, when dy by dx equals 6x, take 4, and the curve passes through the origin. All right. Oh, hello. Given f prime of x equals x to the negative half and f of 4 equals 10, find f of x. F of x equals 2x to the half. In other words, 2 times root x plus c. Then 2 times the square root of 4 plus c equals 10. So c is 6. So f of x equals 2 root x plus 6. So f of x equals 2 root x plus 6 when f prime of x equals x to the negative a half and f of 4 equals 10. A curve has dy by dx equals 3 take x and passes through the point 2, 1. Find the value of y when x equals 0. Okay, if dy by dx equals 3 take x, then y equals 3x take a half x squared plus c. So c is negative 3. When x is equal to 0, y would be equal to negative 3. So y is equal to negative 3 when x is equal to 0 on the curve where dy by dx equals 3 take x and it passes through the point 2, 1. Okay, next up, definite integrals. Oh boy. Integrate from 0 to 2, 3x squared dx. So evaluate from 0 to 2, x cubed. So 2 cubed take 0 cubed. So 8. So 8 is the value of the integral from 0 to 2 of 3x squared dx. Integrate from 1 to 3, 2x at 1 dx. So evaluate from 1 to 3, x squared add x. 10. So 10 is the evaluation of the integral from 1 to 3 of no, I've forgotten. Alright, I have to do it again. Evaluate the integral from 1 to 3 of 2x at 1 dx. So evaluate from 1 to 3 x squared at x. Which is 12 take 2, which is 10. So 10 is the evaluation of the integral from 1 to 3 of 2x at 1 dx. Evaluate the integral from 1 to 4 of x to the negative a half dx. So evaluate from 1 to 4 2 root x. The answer is 2. So 2 is the evaluation of the integral from 1 to 4 of x to the half dx. No. 2 is the evaluation of the integral from 1 to 4 of x to the negative a half dx. Hello. Evaluate the integral from negative 1 to 1 of x cubed dx. This will be 0. This will be 0 because x cubed is an odd function. So 0 is the evaluation of the integral from negative 1 to 1 of x cubed dx. No, those were painted by my friend. Integrate from 1 to 2, 4x to the negative 2 dx. So evaluate from 1 to 2, negative 4x to the negative 1. So evaluate from 1 to 2, negative 4 over x. So that's minus 2 minus 4. It's minus 2 plus 4, which is 2. So 2 is the evaluation of the integral from 1 to 2 of 4x to the negative 2 dx. Okay. Areas under curves now. Hello. Find the area bounded by the curve y equals x squared, the x-axis, and the lines x equals 0 and x equals 3. This is the same as evaluating the integral from 0 to 3 of x squared dx. Which means evaluate from 0 to 3, a third of x cubed, which is 9. So 9 is the area bounded by the curve y equals x squared and the x-axis and the lines x equals 0 and x equals 3. Find the area enclosed between the curve y equals 4x take x squared and the x-axis. Okay, so we need to find the roots of y equals 4x take x squared. That's correct, isn't it? Yeah. We need to find the roots of y equals 4x take x squared. And we'll do so by first factoring out x. So y equals x, open brackets 4, take x. The answer is 0 and 4. And now integrate from 0 to 4, 4x take x squared. So evaluate from 0 to 4. Two x take a third of x cubed. Which would be 8 take a third of 64. Which is totally wrong. That's totally wrong. Try again. Find the area enclosed between the curve y equals. Find the area enclosed between the curve y equals 4x take x squared and the x-axis. Okay, so obviously it's a parabola that's opening downwards, and we have to find the roots. So y equals x, open brackets 4 take x. So the roots are 0 and 4. That's correct. Okay, so integrate from 0 to 4, 4x, take x squared. So first evaluate the integral. And that would be 2x squared take a third of x cubed. Just plug in 4. (32) take 64 over 3. So 32 take 21 and a third. (10 2/3). So 10 2/3 is the area enclosed between the curve y equals 4x take x squared and the x-axis, right? Okay. Find the area bounded between the curves y equals 1 over x squared and the x-axis and the lines x equals 1 and x equals 3. So integrate from 1 to 3, 1 over x squared dx. 1 over x squared is x to the negative 2. And integrating that, we get minus 1 over x. So evaluate from 1 to 3, minus 1 over x. Top limit, minus 1/3. Subtract bottom limit, minus 1. So minus 1/3 plus 1, which is 2/3. So 2/3 should be the area bounded by the curve y equals 1 over x squared and the x-axis and the lines x equals 1 and x equals 3. Hello? Find the area bounded by the curve y equals 3 root x and the x-axis and the line x equals 4. Okay, so the curve y equals 3 root x has a root, namely 0. I mean, it's a parabola opening up towards the right, whose center is the origin, but it's only a half parabola because it's the square root of x. Anyhow, we visualize the two roots being 0, but, well, the root being 0 and the line in question being x equals 4. Now, that would mean we have to integrate from 0 to 4, 3 root x dx. 3 root x is 3 times x to the half. integrating, we get 2x to the 3 over 2